Alright, so I believe this is recording. Let's take a look. We're looking at log properties. Um, we want to the directions here. They want us to find a numerical value for this log base A of 12 given this other information. So I need to rewrite 12 and try to use these numbers 6, 2, and 5 to do that. So 6 times 2 is 12. So I can rewrite this as log base A of 6 times 2. And by properties of logarithms, if you have multiplication, you can write it as the sum of logs. Log base A of 6 plus log base A of 2. Well, they give me that 6. They give me the value for the first term. They give me the value of the second term in the directions. So we're done. We can get our final answer by adding this together. I don't want to make a silly mistake, so let me use the calculator to add these decimal numbers. 2.711. Alright. Let's look at the next one. I've got 25. I need to rewrite this 25 with using either 6, 2, or 5. I'm going to use 5. I know that the 25 can be rewritten as 5 squared. So I have a power rule that says if you have an exponent, that exponent can come down as a coefficient. And by substitution, it tells me what the log base A of 5 is. And again, I don't want to make a mental arithmetic error, so I'm going to come in here and use the calculator, my online calculator. .512. Alright. How can we rewrite this with 3? Well, let's look at this as 3 over 1. And now, let's pull a trick that's common in algebra. Multiply by the number 1, but to write 1, I like to joke around and say, in disguise, I'm going to write the number 1 as 2 over 2. Okay, so when you multiply fractions, that's pretty easy. You multiply the numerators together, that's 6. You multiply the denominators together, and that's 2. And we have a property of logarithms that says if you're taking the log of a fraction, that you can take the log of the numerator minus the log of the denominator. Now these all have to have the same base, or those properties don't apply. So this gives me the log of 6, 1.955 in the directions. It gives me this value, and I subtract 0.756. So if we key this into the calculator, 1.955 minus 0.756. 1.199. If make sure that I've keyed that in correctly. I haven't made a data entry error. I don't think I have, and I don't believe I've made an arithmetic error above, so I think that's my final answer. Alright, let's take a look at the next one. Make it bigger so we can see it. So I have a 2 and a 5, so I don't have to multiply by 1. I don't have to do anything special with this. The log of a quotient is the difference of two logs. The log of the numerator minus the log of the denominator. So by substitution, 0.756 for the first term, and the second term, 1.756 if I have read those values off correctly. I know the day is coming where I need glasses because it's getting more and more difficult, especially with these exponents, to read the correct. And this calculator online Oh, I should have seen, look at this. I should have seen that difference is -1. I didn't need a calculator for that. All right. Let's look at 150. Well, I know that 150, if I had 15 times 10, 15, 3 times 5, 10, 2 times 5. So playing around with this, I know that 150 is equal to 2 times 3 times 5 squared. Alright, so I have a 6 and I have a 5, so the 2 times 3 is 6 times 5 squared. So that's how I want to rewrite this. Alright, so keep that in case you need to refer to it. Instead of 150, we'll rewrite 150 as 5 squared times 6. Now that I have multiplication, I can write this as log of 5 squared plus log base a of 6. By the power rule, this 2 as an exponent comes out in front as a coefficient, as a multiplier. And now I can look at my given information and substitute in my decimal numbers and I'll be done. So I've got 2 times 1.756 plus 1.955. Alright, so I've got 2 times 1.756 plus 1.955. So, this is my final answer for this problem. Hopefully, I didn't make any silly... That's a 7. That's hard to read, isn't it? Well, you can see it from the... I don't even know why I'm writing it down. You can read it right off the calculator. Alright. I have multiplication, so I can write that as the sum of logs. Log base a of 5 plus log base a of a. They tell me that for this first term that it's 1.756. And a to what power gives you a? Well, a to the first power. So 2.756. I didn't even need a calculator for that one. Hip hip hooray. Alright, so let's see what we have here. Make it a little bit bigger. Let's write the single logarithm as the difference of two logarithms. The log of the numerator minus the log of the denominator. Alright, so a to the first power is a, so this first term is just an unusual way to write the number 1. And the second term, they've told me that the decimal approximation for it is 1.955. So if we subtract that, we get negative 0.9. Alright, so I hope that helps. Oh, we still have a few more. I thought we were done. Alright, we have multiplication here, 6 times a to the 4th. So let's split this up into two logs. The log base a of 6 plus log base a of a to the 4th power. Well, I can replace this log base a of 6, 1.955. I can take this exponent by the power rule and pull it out in front of 4 times the log of a base a. Well, that's just the number 1. This guy, remember, a logarithm equals an exponent. A to the first power is a. So 1.955 plus 4. And that's what I get. Alright, now let's take a look at this one. Even though I have a fraction there, I have to deal with this exponent first. So I've got 3 times the log of this fraction. So remember, it's 3 times, well, this guy that follows. What follows here, I'm going to write it as a subtraction, log of the numerator minus the log of the denominator. So I need parentheses around that because both of those terms, that whole thing gets multiplied by 3, not just part of it. So you can see up above the whole thing, 3 times this. Well, if what I've highlighted in yellow there is the same number as here, both of these get multiplied by 3, so I have to distribute. And I've got 3 log a of 6 minus 3 log a base a. They tell me that this second factor right here is 1.955. And a to the first power is a, so this is just minus 3 times 1. See, this guy right here is just the number 1. So let's go to the calculator so we don't make a silly mistake. 3 times 1.955 minus 3. So I'm getting 2.865 if I haven't made a silly type of error. Alright. Hey, I hope that helps, and I'll talk to you later.